Hello.
Good morning, sir.
Good morning. Actually, your mic was mute. That was I
Yes.
just
I,
going to ask. Okay,
I
Pratham.
want, sir,
Good
can you give
morning.
me the permission to record?
Yes. Okay, I
Can
am
you give me the?
recording. I am recording. I will be sending the entire recording to you. Okay.
Okay,
Okay.
that's also.
Okay. Pratyaksh, you already know that we will be talking about Arduino UNO basically. May I ask you if you have done anything on Arduino before, or do you know anything regarding Arduino, or what is it? Do you know anything?
I know
Just
something according to Arduino.
okay.
Arduino is a programmable device
Okay. Good.
in which we can give a set of instructions
Hmm.
so that the motor or the device can perform that.
Okay. So you have a basic idea what is Arduino. So first of all, let me show you what how the Arduino looks actually. See, this is an Arduino board. Okay,
Okay.
this one is an Arduino board, and you can see that many ports are present over here. Many holes are
Yes.
there. Okay,
Yes.
and black color thing is over here, and another box like thing is present over here. I will be describing all these things to you. Now you will all see another black chip present over here. My finger is
Yes.
pointing there. Okay.
Yes.
Okay. Now one by one, I am going to elaborate all these things to you. See,
Okay.
as you said that Arduino is a programmable device. Yes, it's a programmable device. It's actually a board which can be used to develop projects. Okay. So that's
Okay.
why Arduino is also called a development board. Okay. And it's not a microcontroller. Arduino is not at all a microcontroller. Microcontroller is this one, this black chip.
Okay.
Okay.
Yes.
Its name is,
Is it an integrated circuit?
yes, it's IC. Obviously, it's an IC. Its name is Atmega 328P. Okay. Can you tell
One
me
second.
why its name is Atmega 328P? Can you guess?
No.
See what happens. Every IC needs some stored data. Actually, if you want to write, you can tell me. I will stop. Okay. Okay. So the IC
What is
present
the name of the integrated circuit? Can you just
Atmega
like
328P. ATMEGA 328P. Okay. So
Atomega?
328. 328P.
Okay. Thank you.
Now, every IC, every integrated circuit needs two things. First thing is space, where it can store data, and third one is the data transmission speed. Second one is the data transmission speed. So, because without
One
data
second.
transmission speed, it can't. Actually, I will write those things in Notepad. I will write those things. Then it will be much easier for you. Now, please listen to me. Otherwise, you will not be able to understand. So, what happens? The every IC needs two things first. First is and then a speed to transmit data from it to other devices, or from to in order to get data. Then we need that speed to gain the data from other devices. So
Okay.
that's why Atmega 328P has 32 kbps of speed of data transmission. Okay, and 8 bit of flash memory is there inside it. Okay, that's why its name is Atmega 328P. Okay, so that's the main reason why its name is like that. Okay, so I have shown you the Arduino board. Now you
Yes.
will think that what is this one? See, this one is a DC jack port. What is a DC jack
DC.
port? I guess you have
From which
seen
we can
yes, yes.
from which we can connect our laptop or a computer to it.
No, no. This one, the laptop or a computer port, that is this one. This one
Okay.
is the port where we can connect an adapter. If you are not using a
Alright.
battery, okay, what we can do, we can put the adapter in the switchboard, and then we can insert the A to B, the the pin part inside this, and it will get power. Okay.
Okay.
So we can use the adapter part over here. Adapter is pin part inside this black portion, and this box shaped thing, which is of silver color, is nothing but an Ethernet port. You can see that it's an Ethernet port. Inside this wire goes in. Okay.
Okay.
This one goes inside the Arduino UNO. You can see that. See, I am holding this and I am just fixing it. Okay.
Yes.
And this part goes inside any laptop or computer that you are using. Okay. This was USB A to B. The B part is the part which goes inside Arduino, and this is the A part which goes inside the computer or laptop. Okay. Through which you are controlling the Arduino board. So okay, this is USB A to B. And can you tell me why this USB A to B is needed? Not in technical
Yeah.
word, normally.
The USB A to B is used such as the A jack is connected to the computer or the laptop, and the B jack is connected to the Arduino board.
Yes, yes. And why we are connecting them?
We are connecting so that we can give a set of instructions or do programming in the Arduino board.
Yes, we don't do programming in the Arduino board. What we actually do is we code everything on our computer and we send those codes. Actually, codes are nothing but set of instructions, right? You already know that codes are nothing. These are set of instructions. The instructions which we want the computer to give, and the computer will then
transfer it
send them
from the jack to the Arduino board.
Arduino board through with the help of this cable. Okay. So now I will show you where we do the coding of Arduino. Okay. Okay. Let me share the screen, and I will be showing you where we do that. So you can see that a software called Arduino is present in my laptop. So I am clicking on it. It will start. So it has started, and this is what you will see.
Yes.
Okay. At the very beginning, you will see this. You can see that two loops are present over here: void setup and void loop. The rule to write code for Arduino is we mention the pin configurations and those pin details. Pin means these holes. These are the holes, right?
Yes.
These are the holes where in which hole we are connecting a particular device to. All these informations are written inside this void setup. But
void setup, in the void setup we write all these things, and in the void loop, void loop we write
the main code, the main logics. Okay, the main logics, what these pins will do, all that activities will be mentioned inside void loop. Okay, and all the initializations, that means telling the details, all the details of pins and everything are written inside this void setup. Okay. When we will start the regular classes, I'll be telling these things again, and I will be writing them. I will be providing you study materials, so it will be much more easier to you, and it will be not a problem. These are very basic things and very easy. But before this, before void loop, before void setup, we need to do some more things. In this part, we declare. In this part, we declare the variable. Okay. If we are connecting an LED, in this one, what we are doing, we are connecting an LED. You can see that an LED is present on the board, and there are on the breadboard. On the two, there are two wires, and for one for the ground and one for the digital pin to which we will be connecting. So I will have to take a variable with the name, let's say LED pin, okay, or LED. I will declare a variable called LED, and then I will declare, see, I will have to write const, and then I can
what
write.
Does const mean?
Const means constant. I was just going to tell you. Const, why we are writing const? Because the pin number will not change, no. the jumper cable, these are called jumper cables. These wires will not come out and go to another position, right? They are constant. They will be same as far as the pin numbers are concerned. So first of all, we are writing const, then we are writing int.
Okay.
I guess you know about int a bit. Int is something. Int is a data type. Okay. Int, char, float are the data types. Int stores integers. Why we are writing it? Because the if we are connecting to digital pin 8, then what 8? What is 8? 8 is an integer. Okay.
Okay.
That's why we are writing int over here, and LED is the variable which we are using, and LED connected to digital pin 8. Now I will be coming to what is digital and what is analog. Okay. And
Yes.
because in the Arduino board which you are seeing in this Arduino board, there are some slots. One slot is
Yeah.
over here, one slot is over here, and another long slot is over here. Okay. This long
Yes.
slot from the very beginning to the end is the digital pin section. Okay. And this one is the analog pin section, and this is the
I
power
actually
section.
cannot see.
Okay, I will be sharing
Cannot
the screen. I will be sharing the screen, and I will be showing you the picture of Arduino. Then I will be easily pointing with the cursor, with the help of the cursor, and you will easily see that. Okay.
Okay.
Okay. So let me go to. So for since you know that all the classes will be conducted online, we will be taking the help of this website, that is Tinkercad. Okay.
Yes.
To Tinkercad, and here we will be able to make all the connections. We will not require anything. So we will go to create new design. Oh, sorry. First of all, we will have to go to circuit. Here we have to choose circuit, because we will be dealing with circuits now. So after clicking on circuit, we will have to click on create new circuit. And as soon as we click on create new circuit, a page will come in front of us. See,
Yes.
you can see that many things are present over here. Resistors, LED,
Sir, LED push
push
button.
button. Yes, yes, yes.
So
So
where's
all
transistor?
then you can see the battery is present over there. Here is the Arduino board which we were looking for.
Okay.
Okay, here is the Arduino board. Now let me tilt it a bit. Okay, now I guess you can see that some writings are over here. See, power is written in this section. In this section, you will get all the pins which are required to provide power to the devices that we will connect to the Arduino. Okay. If we connect, let's say, if we connect LED with Arduino, okay, this is the LED. And how we connect in Tinkercad? In Tinkercad, we go to these strands of the devices that we are going to connect. Okay. And we drag them, and then we connect. Okay.
Okay.
Like
This is the
this.
negative point.
Yes, this is the negative part. But forget about these things. First, let's recognize which are the parts and what they do. Okay. So in this section, in the power section, what actually happens? The pins which provide power to the devices that are connected are already present over here. 5 volt, 3.3 volt, two grounds are also there, an input voltage slot is also there. So this is called power pin section. Now you will find analog section and an entire digital section. Do you have any idea regarding analog and digital?
No. Analogs are for continuous flow, which are used for scientific reasons also, and which give us the data continuously. And digital is the things that which work on binary digits.
Yes, the digital works on binary digits, zeros and one. Okay, but you said that analog works in gives output continuously, but digital also gives out output continuously. Okay, see, the basic difference between analog and digital is if you have a watch in your room which is analog, you can see that. Look at that watch. If you have a watch in your room, analog watch.
Yes.
Okay, look at that watch only now. Okay. Now, if I ask you what is the time, first of all, you will have to look at the short strand, at which part it's
Yes.
pointing. Then you will have to look at the watch. Don't look at me, okay? Then you will have to look at the longer strand where it's going. Then you will have to do the mindstorm. The brainstorming will be there. And then you will come to a conclusion that okay, the time is this. But if it was a digital watch, now look at me.
Yes.
But if it was a digital watch, you would have looked at it and you would have said, okay, this is the time. In analog and in digital, the basic difference is human brain needs to work more in case of analog, and human brain needs to work less in case of digital.
Yes.
As human brain works more in analog, that is why manual error percentage is greater. The chance of getting wrong is greater in analog, but the chance of getting wrong in digital is lesser. Okay.
Yes.
If I try to discuss the waves of both digital and analog, in digital we deal with only two situations, either 0 or no, 1, either on
Yes.
or off, either high or low, right?
Yes.
But as far as analog is concerned, every time has its own value. Value changes from time to time. That's what you are saying. The wave is continuous. Okay. Okay.
Yes.
Okay. Now we will be starting with okay. Can you let us play a short game? Can you tell me 5 digital devices in your room right now?
Mobile,
Yes,
laptop,
and
Alexa,
okay,
and there nothing. Only three speaker and one LED and one light stand.
and the tube light.
Yes.
Tube light is also a digital. And now 5 analog things. Can you name them?
Clock.
Yes.
Then only one analog thing and nothing else.
Okay. So these are the basic differences and examples of digital and analog. Now let's try how to do a particular task. The very simple and the first task that we do with Arduino is connecting an LED to Arduino and then just lighting it up. Okay.
Yes.
So let me tell you, the two parts or the two strands of LED are, one is positive, one is negative. Okay, let me show you an LED. See, now I will be showing you an LED and you will tell me what is the difference between these two strands. Okay.
Okay.
See, this is the LED and these are the
I
two
cannot
strands.
see actually. Your cursor is not moving.
Can you
Yes,
see
now
now?
it's moving. Yes, yes, yes.
Can you see the difference?
Yes, yes.
One strand is longer than the other.
Yes.
Okay. The longer strand is positive and the shorter strand is negative. Okay.
Yes.
Here in this Tinkercad, you will see that the longer strand, the analog strand is a bit tilt. Okay. And the another one is straight, but both are
Yes.
similar. If we tilt a longer one, then only both of the strands will be similar, right?
Yes.
Otherwise this strand would be longer. So it shows that the right hand side strand is longer than the left hand side strand. Okay. Now the shorter strand is always negative and the
Yes.
longer
Longer strand is always
positive.
positive.
Now can you tell me why we have the positive part, we will be connecting it to the Arduino or we will be connecting it to any battery or anything, it will glow. Why do we need the
Yes.
negative part? Do you know?
Yes, because for to collect the negative electrode.
Yes. What happens according to the principle of electricity or current flowing principle? Current will only flow if there is potential difference. And what is potential difference? Is a very easy thing. Potential difference is if I am talking about a steel rod, okay,
Yes.
the current will flow from the right hand most part to the left hand most part because both of them has a difference in between them. Okay, the two extreme sides are called potentials and the difference between them is called potential difference. Here one side is plus, one side is minus, so they are opposite to one another, right? So they have a difference
Yes.
among themselves. That's why if there is difference, current will flow. Okay, current will flow in any difference. That's why one part is positive, another part is negative. With only
Yes.
positive, the LED will not glow. With only negative, the LED will not glow. Both are required because both form the difference, and without the difference, current will not flow. And if current does not flow, then light will not glow. Okay. So now we will be connecting the LED. See, we are connecting the LED now. Where should we connect the negative part? You tell me.
5 voltage.
No. See,
GND.
yes, GND is the part where we always connect our negative parts to. Can you tell me why?
No. Ground.
Yes,
Ground.
its name is ground. Its name is ground. That's right. But do you know what is the main job of ground? Okay, tell me one thing. You are in which floor? Right now, you are in which floor?
First floor.
How can you tell me that this floor is first floor?
Because the ground floor. Because because there are stairs.
Leave stairs. How can you tell me that this is the first floor of the building?
Because because the ground floor. Because the ground floor is down and the first floor is up.
Right. So what you are doing, you are taking the ground or the road just beside which your home is there. You are taking the ground as a reference. Okay. From ground, I am this much up. So I am in the first floor. Under me, there is the ground floor. So you are taking the floor as the reference. Okay. Here also, the ground is the reference and 5 volt is this. Okay. The difference between the ground and the 5 volt. Since there is difference, the current will flow, right? Since current will flow, the light will glow, right? This is the
Right.
main point that I was trying to elaborate. So we have connected the ground. Ground is always negative. Actually, what happens? Ground provides negativity to the circuit because without negative you can't see this difference, right? So now what we will do? We will be connecting this positive strand to 5 volt. Okay,
Okay.
let's connect it to 5 volt.
What will happen if we connect it to the 3 volt?
3.3 volt. Nothing will happen. It will be okay. Okay. Now, after doing the connection, what we do? We do the coding. But I will be coming to code. First of all, after doing the connection, we go to start simulation. Okay.
Yes.
See, it's being initialized. And see, the LED is glowing. Okay. Why the LED is glowing? Because we have provided all the required things to the LED. We have given the positive wire 5 volt. Whatever what it needed power, we have given it 5 volt power. The negative strand needed negativity, we provided ground. Okay. So it is glowing. But here is the main problem. If we want to control the LED, how can we do that?
Using a Arduino board.
Yes, perfect. because right now also we are using Arduino board, but instead of Arduino board, if we used a battery also, then also the LED will easily glow, right?
Yes.
But with Arduino, what do? We control the devices that are connected with this, right?
By giving a set of instructions.
Yes, by giving a set of instructions. Now, how
Such
can we?
as glow after every 10 seconds.
Yes, we can do that, but for that we need some more thing. And what is that? We need
Coding.
this digital pin, right? Because this is the pins which will make me which will allow me to control this device. Okay, because these are power pins, but from analog to digital, all these are logical pins. I can put my logics only over here. All these are just like robot. I will switch them in, I will just put the wire and it will glow. And where we can put my logic, only there I can control the devices, right? For 5 seconds, for 10 seconds, whatever. So now I controlling the devices logically. So what should I do? I will take this wire
And connect it to the.
any of the digital pins.
Yes.
Okay, I'm connecting it to 8. Now you tell me, why have I connected the LED to digital pins?
We have connected the LED to the digital pin so that we can do logical instructions
Yes.
and set up for instructions.
Yes, but we could have also plugged it into an analog pin. But why did we do it in digital?
We did it in a digital pin so that we can give a set of instructions and it can follow it.
In analog also we can do the same, but why did we do that in digital? First tell me, LED is what kind of a device? Digital device or an analog device?
Digital device.
Yes. Since LED is a digital device, that's why we are connecting the LED to the digital pin. Okay.
Then why are we connecting the cathode of the LED to the analog to the analog line?
No, it's not analog section, it's the power section. From A0 to A5 is analog section. Okay.
Oh.
See, this is the power section. We could have connected to here also. We just needed a ground. Wherever the ground is, we can connect the negative part of LED to that. Okay. So we have connected the positive strand to 8 and the negative strand to ground. Okay. Now we will start doing the code. Okay. Here we will do the code and we'll have to choose how we want to do the code. We will do the code in text. See, a code is already written over here. We will just modify it. As I said, first of all, we will mention the variable that I am going to take.
Then is IST.
What?
IST. Const, then IST.
INT, int, integer, INT. Const, int, then I'm writing let pin. Let's say it's the name is let pin. Is the variable will be taken for the pin to which we are connecting. We are connecting to 8, so I am writing 8 over here. Okay. Here we need to mention two things. First thing is we need to write serial dot print. Okay, and within serial dot print.
What does this mean?
Yes, I'll be telling everything. Wait, 960 and this. Now, in the first line, we have written const int let pin equal to 8. We have written const because the pin will be same. It will not change throughout the code. Let pin is the name of the variable which we are using. See, we can't get inside the computer to change anything, to process anything. What we can do, we can give instructions and everything to the variable or the number to which we are connecting, and like this we can control the machine. And then inside void setup, I had already said that we will be mentioning the details of configuration, pin configuration. So I am connecting the LED to 8 So I'm writing 8 over here, and before that serial dot print, sorry, not print, serial dot begin 9600 will be there. See, 9600 is the frequency at which works the base. Okay, the 9600
How
is
do
called,
you know that it is 9600?
yes, I have written that 9600 is the frequency at which Arduino works best. It's called baud rate, BAUDRATE, baud rate. Its name is baud rate, and before that we write serial dot begin. See, the communication in between Arduino and the LED after being connected is serial communication. Okay, they will be sending instructions among themselves, and the name of this communication is serial communication. Here, as soon as we write serial dot begin, that means we are saying that serial communication please start. Okay, Arduino is asking the serial communication to begin, and the serial communication goes on in the frequency of 9600. Okay, this is called the baud rate. And after that, pin mode is another thing. Inside pin mode, we first mention the pin number at which we are connecting, and then we mentioned input or output.
Yes.
Now, can you tell me, LED is an input device or an output device?
Output device.
Why?
Because it shows us the result that the LED is glowing.
Yes. If it was any kind of a sensor which gathers knowledge from environment and then gives it to the Arduino, then only it could have been input device. These are all output device, lights, speakers, all these things are output devices.
Like yesterday only, I did a project in my breadboard.
Okay.
It was of the LDR. It was a dark sensor.
Okay. LDR, light dependent resistor. Light dependent resistor. Its full name is light dependent resistor. Whenever you make a shadow or make a darkness over there, the LED will glow up. This is the principle of it. So 8 is our output pin. So we are mentioning the nature of the pin just beside the number of pins. After that, in order to control the LED, what do we write? Digital write. Because it's connected to digital pin, we are writing digital write. And writing means doing something. Reading means just seeing something go. But writing means executing something. Okay. So digital write 13 high. 13 high means 13 not, it will be 8 because we have changed the number. 8 high, 8 low. 8 high, high means on. That means the LED will glow up. And glow up for how many seconds? 1 second. It's written in millisecond. 1000 millisecond is equal to 1 second. And delay.
But I have a question, sir.
Yes.
Sir, how did you get to know that the frequency of the Arduino UNO board will be 9600 only?
It's convention.
Okay.
It's the convention. Okay. So if we delay is 1000, and delay, what is delay? Delay is a command which shows us for this much time the entire task will be going on and on. Okay. After 1 second, the 8 will be low. The 8 pin will be low. That is, the LED will stop glowing for 1 second. Again, it will start glowing. Again, it will stop glowing. So for 1 second interval, it will glow and it will stop glowing. Okay. So let's simulate the entire thing like we do. Okay. So I am clicking on start. See, it's glowing and it's stopping, right?
Yes.
Now, if we want to change the time count of glowing, what we can do? We will just.
We can change it to 2000 milliseconds and 1000 milliseconds again.
But first of all, we will have to stop simulation. And then if we want, we can give 3 over here. 3000 and stop for 500 millisecond. That means half of a second. Start simulation. See, we can make it faster also. So what we are doing, we are just playing with the delay. delay command. Again, we are simulating. See, it will happen faster now. Right?
Yes.
Because what we are doing, we are just shortening the delay, so the activity is happening very faster.
In my breadboard, I have to for making the LED flash, I have to do so many things. And in this, we can do it in one thing.
Yes, this is
Like,
simple.
just like writing the coding.
So, did you enjoy the session?
Yes.
It was informative.
Yes.
Okay. Actually, I also enjoyed talking to you regarding Arduino because you know many things that, and I wanted you to know more details on them. So here you can see that the USB A to B has been connected to the USB port. This is the reset button. Okay. If we
Yes,
click
I
on
know.
this, the entire thing will start over again, and it's a reset button. It's nothing, any logical thing is there. This thing is called time oscillator. Okay, which my
Time
cursor
machine.
is pointing. It does all the calculations of time. If we are working with any sensor in which time calculation will be needed, so all this time calculation will be done with this time oscillator. Okay. So again, a short recap. This is the power section, which consists of the voltages which the other devices need and the ground. This is the analog section. We will be connecting analog pin to sensors. Some sensors need analog logical pins. All these pins are digital pins from 0 to 13. All these pins are digital pins. And we also have 0 and 1, which is TX and RX. I will tell these things later on. These are only 0 and 1 we don't connect to, because these 0 and 1 are transmission and receiving pins, transmitter and receivers, which we use for other sensors, that is Bluetooth. When we will be working on Bluetooth, we will be using this TX and RX. Okay, and this is the interface where we do the coding, and we will be stopping the simulation now to stop its job. And if you want to again see our output, we will just start the simulation procedure. Okay, I guess it was
Thank you.
nice.
Yes.
Okay, okay, thank you, Pratyaksh. I hope the class was good. Okay,
Bye.
bye.